Hey guys, welcome back to my channel Study with me. Today we are going to start physics and we are going to start with units and dimensions. Now in this lecture we are let me take laser pen. Need for the measurements. To measure and study phenomena in physics, we have to perform some experiments. Based on these experiments, observations, we develop new laws and theories. For the verification, we need physical quantities, so there is the need of units. So basically, to measure some physical quantities such as length, temperature, etc., we have to use some physical quantities, or we can say it's fundamental quantities. We are going to see it in the next slides. So these are needed to calculate some experiments, observations, and on this basis we develop some new laws and theories. So turning to the next slide now. So units for measurements. Any physical quantity can be measured in the terms of number and units. So we for example we can say 1 meter, 1 centimeter, 2 centimeter, 3 centimeter. There is a use of number as well as unit. That is meter is a unit, centimeter is a unit, and number 1 2 3 4 n. Now the definition of unit is the quantity of constant magnitude used to measure the magnitudes of other quantity of an identical type. So for meter, we can compare with other dimensions such as kilometer, meter, etc. for the calculation purposes. This is basically unit. We have to convert from meter to kilometer, kilometer to uh, any other dimensions. So next, let's turn to the next slide. Measurements always involves in the comparisons with the standard measuring unit, which is internationally accepted. So new scientists come up with different units, which is causing jumbling between the conversion factor. So the internationally accepted units are used to gain and transfer their knowledge and our knowledge. We can easily accept that. So for that, four major units are used, that is CGS, centimeter gram second system, MKS, meter kilogram second system, FPS, that is foot pound second system, and SI, system internationally. This SI unit is largely used in all internationally. So now turning to the next slide. See, here it is written recommended use of international systems of unit. This international system is unit is called as SI unit. As this SI unit is uses decimal system conversion within the system, it is very simple and convenient. So this system is largely used as there is easy and convenient use of this system. So turning to the next slide. So the fundamental quantities and units. So we are starting with fundamental quantities. Let's start with definition. The physical quantities which do not depend on any other physical quantities for their measurement are known as fundamental quantities. See, fundamental quantities are the quantities which does not depend on any other quantities for their measurement. Example, mass, that is in kg only, and length, that is meter, centimeter, etc. The fundamental units are the units to measure fundamental quantities are called fundamental units. To measure these quantities, fundamental quantities, the units used are called as fundamental units. Now turning to the next slide. There are basically 7 fundamental quantities. So let's see which are those. So first one is our length, that is in SI unit it is meter. So now next is our mass. That is the fundamental quantity mass that is measured in kg in SI unit. Here there is written symbols of this meter, kg, of kilogram, and time it is second, and it is symbolically represented as SEC. And temperature it is usually measured in Kelvin. K that is that is the symbol of Kelvin. We actually calculate this temperature by the help of thermometer in degrees Celsius, and we convert it into Kelvin as it is a SI unit. Electrical current that is ampere, and luminous intensity that is candela CD. Amount of substance that is mole, and it is denoted by MOL. So now turning to the next slide. The quantities which depends on any other physical quantities for their measurements are known as derived quantities. So beside the fundamental quantities, the other quantities are derived quantities. So they need some physical quantities help to measure for the measurements are called as derived quantities, and the units used for their measurements is called as derived units. Now turning to the next slide. Here some examples are there. See, SI unit conversion of velocity. So velocity, we know that velocity is displacement per unit time. So unit of displacement is meter, and unit of time is second, S. So we can write it as meter per second. This is raised to minus 1, S raised to minus 1, that is second raised to minus 1. Here this velocity is a derived quantity of displacement and time. This velocity needs other fundamental quantities such as displacement and time for their measurement is called as derived quantity. So here it is the given. So SI unit of acceleration, as acceleration depends on velocity and time, and velocity depends on displacement. So meter per second divided by second. This is completely divided by for your better understanding. So it will be equal to meter per seconds raised to minus 2. Here actually I have to correct it. This is meter per second square. Here I have already written divided by, so here minus symbol should not come. I will correct it while uploading. Okay. Now turning to the next slide. The more examples of physical quantities, physical in that derived quantities. So density is equal to m by v, that is kg per cubic meter. So its dimensional formula is L minus 3 m1 t naught. Naught means 0. Acceleration is given by A is equal to v by t. We have seen previously, that's meter per second square. In SI unit we are seeing, and dimensions formula will be L1 m0 t raised to minus 2, and momentum is given by P is equal to mv, that is kg meter per second. That is in dimension formula we can write it as L1 m1 t raised to minus 1, and force is given as F is equal to ma, that is mass into acceleration. So that is given by kg meter per second square, or we can denote it by Newton. This is also SI unit. We take this kg meter per second square as Newton for easy convenient conversions. So now this has the dimensional formula of L1 m1 t raised to minus 2, and impulse J that is given by force into time. So it is Newton second. We have seen for SI unit of F, that is force, is Newton. So we get our dimensional formula as L1 m1 t raised to minus 1. These are actual this dimension formulas comes from here. See this kg per meter cube. This m is the length, that is meter, and kg is mass, that is m. This is dimensional formulas are denoted by lmt and other SI units. So we can write this as m is m raised to 3, but it is in denominator, so while coming it up it will become m raised to minus 3. So this m raised to minus 3 is l raised to minus 3, as this is length, so we take it as l. And kg has the dimension m, it is as it is a mass quantity, so it will come m raised to 1. And here there is no sign of seconds, that is time, so here is raised to 0. Now our work is given by work is equal to force into displacement, that is fs, that is measured in joule, that is also a SI unit used in day-to-day life. So its dimensions are L2 m1 t raised to minus 2. So kinetic energy is equal to half of mv square. That is also a type of work done. So it is measured in the joule, and the same dimensional formula for kinetic energy as compared to work, that is L2 m1 t raised to minus 2. And pressure is given by P is equal to F by A, that is force per unit area, and we can write it as Newton per meter square, or we can write kg per meter second square, and it is denoted in dimensional formula as L raised to minus 1 m raised to 1 t raised to minus 2. Now turning to the next slide, here are some supplementary units. Besides the 7 fundamental units or basic units, there are 2 more units called supplementary units. These units are usually measured for 3D, three-dimensional measurements. This is the measurement of angles usually. Plane angle, d theta, and solid angle. So turning to the next slide. This plane angle, see, this is a 3D cone. uh, at the center it is O. Consider a cap, birthday cap. You in that the cone at the tip is having some angle from which point O and A are there, and O and B. This is the curve of that cap AB, and it has ds distance of the arc, and R is the radius of OB, or we can say radius of OA. Here OB is equal to OA. The radius is same. The angle between this 3D curve is d theta, and plane angle is given by the ratio of length of an arc of a circle to the radius of the circle, that is ds by r, and it is usually measured in the terms of radian, that is rad. And now turning to the next slide, solid angle. So you can say this solid angle. This is also 3D image. So this is a 3D analog of d theta, and it is defined as the area of the portion of a surface of a sphere uh, to the square of the radius of the sphere, denoted by d phi, d ohm, and it is usually measured in the terms of radian. As it is an angle, it is always measured in radian. Now turning to the next slide, conventions for use of SI units. Units of every physical quantity should be measured represented by its symbol. Units are usually determined by symbol. That's the first point. Now the second, full name of the unit always starts with the smaller letter, even if the name is after a person. And here is the example: 1 Newton, etc. but symbolically for unit named after person should be a capital letter, that is example n, 1n, that is 1 Newton after the scientist Newton. Now turning to the next slide. Now this is a symbol for a unit do not take plural form. For example, force of 20 Newton, and it is not 20 Newton s ns. This change the meaning of this unit, that is Newton second, but we are calculating force and it is having unit as SI unit as 20 Newton. So these are the basic rules which we have to follow for the conversions of units and measurements of unit. Now symbolically for units do not contain any full stop at the end of the recommended letter, that is example 25 kg and not 25 kg dot. This change the meaning of the units. The units of now turning to the next, the units of the physical quantities in numerator and denominator should be written at one ratio. For example, the SI unit of acceleration is meter per second square, and but not meter per second completely divided by second. We have to combine it and make it short accordingly. Now our next point is use of combinations of unit and symbols for unit is avoided when a physical quantity is expressed by the combinations of two. Example, the unit joule per kg Kelvin is correct while joule kg K is not correct, as we have to not write complete word. We have to use only the symbols, that is for joule it is J. If these rules were not made, then we can also we also write that joule J is equal to joule, kg is equal to kilogram, and K is equal to Kelvin, which will become a lengthy. So we are writing in the short form symbolically. Now turning to the next slide, our last point, the prefix symbol is used before the symbol of the unit. Thus, the prefix symbol and the unit symbol constitute a new symbol for the unit, which can be raised to the positive or negative power of 10. That is 1 millisecond. See, 1 millisecond can be written as 10 raised to minus 3 second. 1 microsecond, that is written as 10 raised to minus 6 seconds. 1 nanosecond is equal to 10 raised to minus 9 seconds. And use of double prefix is avoided while single prefix is available. That is 10 raised to minus 6 second is equal to 1 microsecond and not 1 mms, and 10 raised to minus 9 second is equal to 1 nanosecond and not 1 milli microsecond. So now turning to the next slide. In short, we have to use only single prefix, not double prefix in only one unit. So turning to the next slide, space or hyphen must be introduced while indicating multiplication of the two unit. That is example meter per second should be written as meter space second raised to minus 1, or meter dash second raised to minus 1, and not meter second raised to minus 1, because we actually get we actually calculate this wrong meaning, that is ms raised to minus 1 will also become millisecond, that is m stands for millisecond as we have seen on the previous slide. So we can write for millisecond, so the dimensions will be wrong while calculations. This so here space and hyphens are used. Now turning to the next slide, measurement of length. These are the some standard measurements which have been calculated that is given on this page. Now turning to the next slide. Uses of dimensional analysis to check the correctness of the physical quantity to establish the relation between related quantities to find the conversion factor between the units of the same physical quantity in two different systems of the units. So here use of dimensional analysis is basically for the correctness of the physical quantities and relating between the other physical quantities, other fundamental quantities, and this conversion factor between the two units can be done. Now turning to the next slide, types of error. Instrumental error, there are usually three types, that is instrumental error. We're going to start with instrumental error. This type of error arises due to the defective calibration of an instrument. Calibration, it is determine the accuracy. For example, incorrect zeroing of the instrument will lead to such kind of error. If the measurements scale is given wrong, then you will you will calculate all the other things wrongly. So we need correct measurement instruments. Now turning to this next slide, error due to imperfection of in experimental technique. This type of error arises due to defective setting of an instrument. For example, the measurement of volume of a liquid in a graduated tube will be accurate if the tube is not held vertically. So, uh, prop, proper proper instrument settings should be done for reducing the error or eliminating the error. Now turning to the next slide, personal error. This error usually occur due to observer, that is the carelessness in taking observation causes this error. Now our next error is random error. This type of error arises due to the error in the equipment, also called as systematic error. This error is actually due to the faulty equipment. Error could be positive or negative. This type of error cannot be eliminated but can be minimized by using uh, a good type of measurement device. Now turning to the next slide, estimated error divided into three types of error: absolute error, mean absolute error, and relative error. This has some formula. Absolute error, that is a mean is equal to a1 plus a2 plus dot 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 plus an uh, divided by n. That is actually average error. A mean, this am is equal to a mean. So am is can be given as 1 upon n. The summation of I is equal to 0 to n. That will into ai. That is, after putting the value of I is equal to 1 to n, you will get the all values of this numerator. Now mean absolute error is given as delta. This symbol is delta. Am is equal to 1 upon n, summation of I is equal to 1 to n, and mod of delta ai. Now relative error, that is r, that is equal to the ratio of mean absolute error to that of absolute error, that is delta am divided by am. Now turning to the next slide. So thanks guys for watching my video. For more such videos, please subscribe and like my channel Study with me. Thank you guys for watching this video. And the link, I will provide a link in which this PDF would be uploaded on my channel. Thank you.